Hi guys, so today we're going to be looking at chapter 5 section 3, graphing radical functions part 2. And so what we're going to be doing is graphing out a parabola of a horizontal axis of symmetry. So let's say, for example, we're asked to graph 1 over 2 times y to the power 2 equaling to x. And we're asked to identify the vertex and the direction of where that parabola opens. So there are two steps to doing this. First step that we are going to cover is solving for y first. So I want to make sure that my equation is isolating my y value. So I have here solve 1 over 2, solve for y. If I'm solving for y, we have here 1 over 2 times y to the power of 2 equaling to x. And then from here, I'm just going to isolate my y value. So I need to get rid of that 1 over 2. I could multiply both sides by 2. That would get rid of my 2 over 2, or 1 over 2. And then I get here y squared equaling to 2x. And to get rid of the y squared, I need to square root to both sides of my equation. So right here, square root, and I get y equaling to plus or minus square root of 2x. Again, don't forget that it would be plus or minus because we are square rooting by an even index. So once we figure that out, then I want to graph out both of those answers. So I'm going to graph out, graph both y equaling to positive square root of 2x and also y equaling to negative square root of 2x. And so that at least I have two different equations, I will make this y1 and y2. Doesn't really do anything to the equation, it just tells me, shows me that it's like a different y value in a completely different equation. Okay. So from here, let's start off with our original function, which is y equaling to square root of x. When I'm graphing this again, I want to use the main points 0, 1, and 4 because of the fact that those are easy to graph out. So 0 square rooted is just 0. Square root of 1 is just 1. And the square root of 4 is 2. And then once I do that, I can start changing the transformations. So one of the transformations is in y1 where right here we have a 2 inside of our square root. And so it's going to change my axis horizontally, at least. And so just a reminder, whenever it's in the inside of your square root, that means that you're using some type of horizontal shift or stretch. And if it's horizontal, that means that I need to change my whole number and flip it into being 1 over 2 instead. So we get here 0, and I'm changing it by multiplying 1 over 2 to it. That equals to 0. And then this is 1 and 4. All of these are being multiplied by 1 over 2. Multiplied by 1 over 2. I get 1 over 2, and this becomes positive 2. And my y values, they still stay the same. Nothing different, because we are only dealing with horizontal stretches. So only dealing with the x values. And that would be the graph for this equation, the y1 equaling to square root of 2x. So I'll plot that out first. We start off with 0, 0. 1 over 2 goes up to 1. Then 2 goes up to 2. So it kind of looks like an arch that looks like this. Make it a little nicer. Done. Okay. Then the next one. Next equation we have is y2, where this time not only do we have a horizontal shift or stretch, but we also have a negative sign. And so since we already have y equals to square root of 2x, I just need to multiply by negative 1. Negative 1. And since it's on the outside of our square root, then that means that I will be changing my y values because it is a reflection on our x-axis here. So we do deal with the y values here. So I am going to keep my x values the same as the ones over here, but instead for my y values, I'm going to multiply all of them by negative 1. Multiply them all by negative 1 and I get 0, negative 1, and negative 2. When I graph this out, I get 0, 0, 1 over 2 goes all the way down to negative 1, 2 goes all the way down to 2. And so this would be my final image. And again, I'll just make it look a little nicer by moving it along the plots. There. So based off of this, I can identify what my vertex is and where my parabola is opening up. I could see here that my vertex, the lowest point on this parabola, lowest point on this parabola is 0, 0. And so that would be considered my vertex. So this is my vertex. 0, 0 is my vertex. And I see that my parabola is opening up on the right side of the graph. So I will write here that parabola opens on the right. And then I don't have any space, so let me move this to the left more. The parabola opens on the right side. Done. Okay. And that's how you would graph a parabola on the horizontal axis of symmetry. Okay. Last one that we're graphing out is a circle. Now, it's not just any circle. It's a circle which has a center at the origin. So this part's important. Whenever we're looking at center at the origin, that means that the circle's center is at 0, 0. And the center location would be right here then. So this is the center of our circle. Center is 0, 0. Okay. So if that is our center, that means that our radius is going to be around that center area. And so it's also important to note that circles have the same radius all around the circle. So for example, if my circle had a radius of 1, that means that if like we do 1 unit to the right, so like this is 1, 0, this is 1, 0, then that means that everywhere on our graph has to be 1 unit as well. All the radiuses, no matter where it's located, has to be 1 unit away from the center. So same goes for my y-axis. Again, if your x-axis is 1 unit away, so does my y-axis. That also has to be 1 unit away as well. And so when we're graphing out a circle, it's really important to identify what the radius is and your x-intercepts. So we aren't going to use a graphing calculator because we don't need a graphing calculator to identify and graph out x squared plus y squared equaling 16. we are going to actually find that ourselves. And we can do that by finding out first what our x and y intercept is. So find x and y intercept. If I'm going to find my x and y intercept, let's start off with x intercept first. I need to substitute my y value for 0. So from my equation, x squared plus y squared equaling 16, I'm going to substitute my y value for 0. 0 to the power 2 equals to 16. Then that becomes x to the power 2 equaling 16. And to get rid of that square root, I'm going to square root to both sides. And that gives me x equaling to positive or negative 4. So I know that at least for this case, I have 2 points, 4, 0, and negative 4, 0. Then for my y-intercept, I'm going to substitute x for 0 instead. And if I substitute x for 0, then I have here for x squared plus y squared equals 16, I'll have instead 0 to the power 2 plus y to the power 2 equals to 16. And again, it's going to square root my y to the power 2. Square root it, and I get left with y equaling to positive and negative 4. So my ordered pairs are 0, 4, and 0, negative 4. And we can actually graph that out first. So from this graph here, I'm going to make sure that my circle is going all the way out to all the 4s. So we have here 4, 0, negative 4, 0, 0, 4, and 0, negative 4. Cool. And so from here, we can identify what our radius is. Starting from our center, we are moving 4 units to the right, 4 units up, 4 units to the left, and 4 units down. And so because of that, my radius is going to be 4. So step 2 would be then to find your radius. Find radius, which we identified as 4. So radius is 4 units. Done. Okay. So hopefully this helped. Good luck.